Welcome to Networks Professionals.
Welcome, everyone. We always obsess over our fiber speeds and our Wi-Fi bars, right? But have you ever really stopped to think about the sheer magic happening right under your fingertips? You type a web address, you hit enter, and instantly, boom, you are connected to a server sitting thousands of miles away. But how does your phone, your laptop, or your smart TV actually make that initial leap? How do our everyday devices escape the literal walls of our homes to connect to the massive, sprawling, global internet? Well, in today's explainer, we're going to demystify the unsung hero of your network setup. We're looking at the exact mechanics of how data gets out of your house.
Okay, let's dive into this. This is the fundamental question we absolutely need to answer today. When you click send on an email or request a video stream, your computer has to figure out how to talk to a network it has absolutely no direct connection to. I mean, your laptop doesn't have a wire running straight to a data center in another country. It only knows what's directly plugged into it, or what's broadcasting on your immediate Wi-Fi network. So we've got a core problem here. How exactly does data cross the border?
Section 1. The local network bubble. Because without a little outside help, every single one of your smart devices is essentially trapped in a local bubble. And honestly, the key to popping that bubble is usually that dusty, blinking little plastic box sitting in the corner of your living room that quietly does all the heavy lifting while we completely ignore it.
So we have two completely distinct worlds here. On one side is your local subnet. Think of this like your local neighborhood. Your devices can talk directly to each other, kind of like literally shouting across the room to a neighbor. But external networks, the vast global internet, those are entirely different beasts. If your computer wants to talk to a server all the way in Tokyo, local broadcast shouting just isn't going to cut it. Your devices need a designated postmaster, an official agent whose entire job is to handle foreign mail and figure out exactly where to send it.
Which brings us to Section 2. Meet the default gateway. This is the ultimate solution, your designated postmaster, and the absolute lifeline for your home network.
Now, what's really interesting about this slide is the specific wording of this definition. A default gateway is a network device, typically a router, that acts as an access point allowing traffic to flow outside the local subnet. Notice that phrase right at the end there, the gateway of last resort. I know, it sounds like something straight out of a sci-fi movie, doesn't it? But it's highly accurate. When your computer realizes a message isn't meant for a local neighbor, it hands it straight to this critical piece of infrastructure. When it's exhausted all its local options and just has no idea how to reach a destination, it throws its hands up and sends the data to the gateway of last resort.
Moving right along to Section 3, the gateway's superpowers. Let's look at the specific, vital jobs this device juggles to keep traffic flowing safely between your local area network, your LAN, and the wide area network, the WAN.
To make this happen, the gateway's functionality combines three absolutely essential tools. First up is routing. But hey, this isn't just mindlessly passing packets along. The gateway actively consults its built-in routing table to make intelligent hop decisions. It looks at the destination IP and figures out the absolute most efficient path for those outgoing packets, usually passing them off to your internet service provider's router next. Second, it acts as a firewall. This manages that vital security border between your private LAN and the public WAN, using stateful packet inspection to ensure only requested traffic actually makes it back inside. And third, it performs NAT, or network address translation. Guys, this is where the real magic happens. Your home network has tons of devices, right? But your ISP only gave you one single public IP address. So NAT takes the private IP addresses of your laptop, phone, and TV, which aren't even routable on the public internet, and masks them all behind that one public IP before the data ever leaves the house. It tracks every single outbound request so that when the response comes back from Tokyo, it knows exactly which local device asked for it. It's an incredibly smart traffic controller, security guard, and translator all rolled into one. Section 4. How traffic escapes. Let's trace the actual step-by-step journey of a data packet trying to break out of that local neighborhood bubble. Let's move to and see how this builds into a very precise logical sequence. How does your device know when to hand off the traffic? Well, step 1. When your device tries to communicate, it immediately compares the destination IP address against its own local subnet mask. For the tech curious out there, it's actually doing a mathematical operation called a binary AND. It converts both IP addresses into binary and mathematically compares them against the subnet mask to see if the network portions match. Basically, it's a high-speed algorithm asking, hey, does this address exist in my neighborhood? Step 2, If the result tells the device that the destination is outside the local network, it stops trying to find it locally. It immediately bundles up those data packets, slaps the MAC address of the default gateway right on the Ethernet frame, and sends them straight to the gateway's IP. It doesn't need to know the whole route to Tokyo, it just needs to know how to reach the postmaster.
Section 5. Finding your own gateway. Because this isn't just abstract theory. We want to empower you to actually go find your very own postmaster right now. Does the number 192.168.1.1 look familiar? Or maybe 192.168.0.1? Or even 10.0.0.1 for some of you techies out there? In typical home setups, this is the LAN interface of your standard internet router. That right there is the actual address of your postmaster. If you were to type this into your web browser today, you'd likely be staring straight at the login screen for your gateway of last resort.
But if you aren't sure what yours is, there's a really easy way to check. If you're on a Windows machine, just open up your command prompt and type ipconfig. Mac or Linux users, netstat-rn or iproute does the trick. And this brilliantly illustrates how accessible this hidden network world actually is. Just hitting enter on that one simple command pulls back the curtain and shows you the exact IP address your computer relies on to talk to the rest of the globe.
So, we've learned from our source material today that without a properly configured default gateway, your devices are entirely isolated. They can literally only talk to other devices sitting in the same physical room or on the same local network. The default gateway is the singular thread connecting your digital life to the rest of humanity. Which makes you wonder, as we wrap up this explainer, if this one little dusty box is the sole gatekeeper holding back total isolation, what other invisible gateways are quietly controlling the flow of your digital life every single day? Definitely something to think about the next time you hit send. Thanks for learning with me today, and I'll catch you in the next explainer.
Thanks for watching.